Here in 12.9, starting on 698, we have the idea of a random access file. So rather than, again, going through, because we'll see this in the code sample, let's tell a story here instead. The way we have been using files is literally from top to bottom in that order exclusively, right? So we have started at the top, we have read one line of an addressee in their name, address, phone number. We have read to the next addressee, to the next addressee, to the last addressee, and then we have closed our file. And sure, that's some of the work, but the idea of a random access file says, well, what happens if you don't need to move from start to finish every time? What happens if sometimes you need to go a few records deep and then start at the beginning again? What happens if we need to change a record? What happens if we need to look at a previous record instead? So the idea of a random access file is not any different a file than we've been using so far. It's just that instead of sequential access, where we go from record 0 to 1 to 2 to 3, we might have to go from record 0 to 12 to 4 to 19. You get the idea. The way we do that is with seek P and seek G. This is put and get. So this is put is to write and get is to read. So I'm going to let you read over these. We are going to see these later on in our code sample. But really the question here you should have is, why is that useful to me? Because it doesn't seem like it is. And really, when we're working with the actual structure of a file, how many bytes from one place to another, remember, again, that's because we're not working here with a text file. We're working here with a binary file, although we can treat a text file like a binary file, and that's actually what we're doing in the example you see here, is we're treating a text file like binary. But remember, only a small fraction of the overall files that exist out there exist as text files. Everything else is going to be binary because it's smaller, it's faster, it's cheaper, and it requires one fewer translation layer, which means it's even smaller, faster, and cheaper, I guess. So what we could do is say, hey, look, I know if I move 32 bytes from where I am located in the file right now, that's the next record. I can do math on those things. So if I know how many records I have, actually I don't even know how many records, I don't need to know rather how many records I have. If I know how many bytes each record is, and that can be delimited by special characters, right? So I can look for things like the $sign in there. Or even better, if I know that each record is 32 bytes long. That'd be awfully small, but let's just say it's true because it's the number I have right here on page 699. So if I know that each record is 32 bytes long, I can figure out how many records I have by the total size of the file. Now, if I know that my records in my file are in alphabetical order, I can actually do a sort on that. Now I can do a search on that too. So if I do a binary search, I can do this mathematically by byte size if I know how many records I have, which is easy to do because I can tell you how many bytes I have. So again, this is another way to abstract away from a text nomenclature. This will help you get to a binary nomenclature, which means faster, smaller, cheaper.